In this video, I'm going to walk you through the steps on how to solve the equation cosine of 5x plus 7 is equal to 0.0022, and we're going to find the smallest two solutions on the interval from 0 to 2 pi. Because the question states that we need to solve this on the interval from 0 to 2 pi, I know that the answer needs to be in radian, so I want to make sure before I start that my calculator is in radian mode. Okay, so the first thing I'm going to do is I want to figure out what angle would I plug in for cosine that is represented by 5x plus 7. What angle would I put in for cosine so that I get out a ratio of 0.0022? So the first thing I'm going to do is I'm going to solve for 5x plus 7 by using inverse cosine. When I put in 0.0022 for inverse cosine, I find that my angle in radians is 1.568596325. And recall that that can be any multiple. I can add or subtract any multiple of 2 pi, and that will give me the same answer as 0.0022. Now, when we look at the unit circle, there's going to be two places on the unit circle where cosine could be 0.0022. That would be here and somewhere in here, in the first and the fourth quadrant. Because remember that cosine represents the x-coordinate on the unit circle. And there are two places that on the unit circle that x could be 0.0022. That would be here. So we need to find this angle, and then we have another angle that we need to find, which is almost a 2 pi. It swings all the way open. So I know that this angle right here is going to represent my purple angle on my picture here. So I know that 5x plus 7, the angle that I plug in for cosine, has to be equal to 1.568596325, and then of course any multiple, I'm going to add in any multiple of 2 pi. Now to find the green angle, what I'm going to do is, since this is symmetric from here to here, that I'm highlighting in black here, and then here to here, to find the green angle, I'm going to take 2 pi, and I'm going to subtract that purple angle, which is 1.568596325. So my green angle is going to be 4.714588982, and then of course I want to add multiples of 2 pi. So now I have these two equations that I have to solve for x, and recall there's going to be a lot of solutions because we can do any multiple of 2 pi, but what we specifically want for this question is the two smallest that's on the interval from 0 to 2 pi on that first rotation. So to solve the purple angle, what I have here in purple, I'm going to subtract 7 and divide by 5. So I'm going to get 1.568596325 plus 2 pi k minus 7. And then I'm going to divide by 5. Now, when I plug in 0 for k, what's going to happen is I'm going to get a negative number. And that's not on the interval of 0 to 2 pi. Although it would be a solution, it's not going to be one of the solutions that the question is asking you to find. So then, instead of trying 0, I'm going to try plugging in 1 for k. So if I take 1.568596325 plus 2 pi times 1 for k, which would be plus 2 pi, and then subtract 7 and take that answer and divide by 5, I'm going to get that x is 0.170356. Let me fix that. It kind of came out messy and hard to read. So 0.170356. Okay, now when I do the same thing with the green angle here, I'm going to solve for x, I'm going to take 4.714588982 plus 2 pi k. I'm going to subtract 7 and divide the whole thing by 5. And again, if I plug in k as 0, I'm going to end up with a negative number for my solution for x, which is a solution, but it doesn't fall on the interval that they're asking us to find this on. They're asking us to find it on the interval from 0 to 2 pi. So then I'm going to try k as 1. When I plug in k as 1, I'm going to take 4.714588982. I'm going to add 2 pi because k is 1, so 2 pi times 1, which is just 2 pi. I'm going to subtract 7, and then I'm going to take that answer and divide by 5. So I'm going to get that x is 0.79955485878. And so now these are the two smallest solutions on the interval from 0 to 2 pi. Now there are many, many solutions, but we're answering it specifically on that interval.